Good afternoon, everyone, and this is Professor Striegel diving into a bit more about some of the questions with regards to how does what is my IP work and how do the things that we discussed called NATs play together with the various wireless devices that we're looking at. So to start with on the screen, what we have here is a picture that sort of summarizes what's been going on. And for most of you, we've been trying to connect to whatismyip.com or a different site. And you have some sort of a smart device, right? So a smartphone, that smartphone might go through your cellular provider, or it might go through a Wi-Fi access point that goes through DSL or cable, which connects to a local ISP, and the internet, and so on. And so many of you have found out, you said, well, when I open up my laptop, or I open up my smart device, when I go to look at the IP address that comes up, what I ended up seeing is I have something 10 something, I have a subnet mask, I have a router that happens to be coming through on that. And then when you actually go up and fire up what is my IP then, you see something that's entirely different. So in this case, we're firing up my laptop and we see that the IP address is 129.74.238.73, but yet when we looked at the actual IP address that was reported, we saw 1038.241.113, and so this is a bit confusing for everybody. So we wanted to look through in a little bit deeper detail what's going on, right? So if we dive into a couple things, what's happening underneath is something called a NAT. And so what a NAT is it's taking, we talked about this earlier, the notion of our address and it's translating. So what ends up happening is I have my smartphone. We talked about in the lectures in Module 6 how your smartphone talks to, say, a Wi-Fi access point. It gets an IP address, something like 192.168.1.100 or something in the 10-net range. It has a net mask, which tells us which numbers we want to pay attention to for our subnet. There's also a gateway, which is how we get on the internet. And there's probably a DNS address, which a lot of times tends to also be the access point for our home addresses or our home devices. So what ends up happening though is that private address is not public for the global internet, and what is happening is our Wi-Fi access point has actually done a DHCP also upstream to get its own IP address. So it actually has two IP addresses, one that it uses on your local network that your smartphone connects to, and then one for its actual global identity. And you could actually even nest a NAT behind a NAT behind a NAT if you really wanted to. But there's the notion of this DHCP that goes on from the Wi-Fi access point onwards. And what ends up happening then is when we go to connect then, the access point is going to serve as a router. It's going to translate our private address that we had in the 10-net space over to something in the public space based on the combination of the IP addresses that we have involved and the ports that are involved. So for instance, if I wanted to connect to whatismyip.com, my source IP would be whatever my source IP is. I got that via DHCP from the access point. My operating system picks out a source port. DNS will tell me what's the actual destination IP, and we'll go through how to do that in just a moment. 141.101.120.15, that's how you actually resolve whatismyip.com, and then there's a destination port of 80, which if you recall is for web service or HTTP. So this packet is going to go out. In TCP we have something called a three-way handshake, but this packet's going to go out. It's going to try to make a connection. But it's going to hit the access point, and the access point is going to say, well, how do I get back home again? So what the access point is going to do is it's going to NAT. It's going to take this source address and translate it from something that's in the private side of my network over to this particular public address. And this public address is going to be shared with any number of my devices that I happen to have on the private network. And how it's going to do that is it's going to translate an IP and port to a different IP and port. And that IP is all going to be shared, this same IP, and how it's going to differentiate it is it's going to pick different ports then. And so as long as two connections don't line up, we're all good. We have roughly 65,536 of them, so the chances of us running out with all of my private devices are pretty low. And so what ends up happening then is my NAT then takes my local private address, converts it over to a public address, i.e. the public side of my Wi-Fi access point or my router then, and what it does then is it converts probably also my source port then over to the source port that happens to be public then. And my destination IP and my destination port still stay the same, and then inside of my actual device it keeps track. It says, oh, something that happens to be going to 65.8.9.184 when it comes back on the response to port 41083, oh, by the way, internally that happens to be mapped to IP address 192.168.1.100, port number 9057. And this particular device, or our NAT in the middle, is smart enough then to translate them back and forth. So as the packets cross, all it does is it goes in, replaces the informations in the header, and then it merrily marches along. So how did we actually figure out a couple of these things? Well, there's a variety of tools that we can actually use inside of our command prompt if we dive a little bit deeper. So we can use a tool called NSLOOKUP if we wanted to figure out what is the actual IP address of a remote site. And when we type in this, it actually goes out and it talks to my remote site, and it gives me whatismyip.com, comes back with two different addresses, and you can't quite see that because it's off the screen, but what we end up having then is we have two different potential IP addresses where it lives, and we could go to either one and they're both valid. Because a lot of times in the cloud we want to have a little bit of redundancy to my servers, so try either one of these and they'll get you to your destination as advertised. I can also, if I would like, I can ping it. So I can go out and I can say I want to ping whatismyip.com. It's going to start sending packets there and back again. So as this is going on, we see a couple of things as this is happening. It's sending a very small packet to this particular IP address, which we see it picked one of those two. It's sending it out. We see TTL as the time to live, kind of how many hops that it take to get there. And we also see time. This is referring to the RTT, or the round trip time. So we see from here where I'm at Notre Dame, it takes us roughly just about 12 to 13 milliseconds to get there and back again, sometimes spiking up to 20. We're going across a little bit of Wi-Fi, but we see we didn't have any loss as we happen to be doing that right there. So we can also, if we'd like, some of you ran into a few issues with traceroute, but we could also go out and we could do a traceroute and say traceroute whatismyip.com. And when we go and we run that, we can see for each of the different hops, we actually get back the results. We see, oh, it probably goes through a Wi-Fi router, QoStaff Wi-Fi 2.BG4. It goes through some sort of a core switch at Notre Dame. Somebody didn't respond in the middle, and then we see, oh, there's probably a gateway router that we happen to have there. We go into Indiana and the Gigapop, which happens to be a gigabit network backbone in the state of Indiana. We go to something it couldn't resolve. Then we go out to another autonomous system in the middle, and then we finally reach whatismyip.com. Now, for many of you, you might not have seen anything when you went out and you did the trace route. So when you went out and did that, if you say trace route, and we come out here, and you tried to go www.nd.edu, you might have seen that a whole bunch of them just kind of sat there and waited. And that can be because not all routers actually need to respond, because responding to these sort of control messages takes a bunch of time away from doing normal internet packet routing. So sometimes we'll just get a bunch of timeouts. No response that happens to be going out there. So you're welcome to try a couple of different nodes for checking out traceroute and how those things work. I hope you found this video helpful then for distilling some of the issues with what is my IP and looking at how NAT works and the difference of why do you see one address on your device versus what you end up seeing as the publicly or globally advertised address on how you actually connect it to the remote site.